if you think about a lot of the jobs we do, including personal computers and, we have Microsoft Word, PowerPoint, a lot of it are tools, technology that help us do that. But it's basically a lot of steps, very laborious. And we can think of a lot of the new wave AI models as essentially simplifying those steps. And once we do that, that's such a huge unlock for humanity that I think it'll create more jobs rather than just destroy jobs, because there are many companies that just won't be feasible using basically our current set of technologies.
Hi there, everyone. A belated Happy New Year from me. It's my first time back on the platform in 2024. I hope you are all extremely well. I'm joining you as usual from London, a very chilly London. And we are in for a huge treat today, because today we have a special guest. His name is Pradeep Ravikumar. He is a professor of machine learning at Carnegie Mellon University. And he's here, of course, to talk to us about AI. We've all watched this AI moment that we've been living through for the last 2-3 years in amazement, with wide-eyed wonder, essentially. I want to dive deep into that with Pradeep in this session. We'll look at where things are heading in 2024, how things are going to develop, the moves we think some of the big players, including OpenAI, will make. But we'll go deeper than that. I want to look with Pradeep at the issues that form the center of his work. I think it's fair to say that he believes that we're at a crucial threshold moment for machine intelligence. And I want to dive into that and what it really means, what it means for where all this is heading, and the impact it can have on the real economy and our lives. So without further ado, Pradeep, thank you so much for joining us. How are you?
Yeah, I'm doing great. Also chilly in Pittsburgh, but still doing great.
Right.
Thanks for having me.
Thank you so much for joining us. And I hope we can both stay warm during this conversation, warm enough. So look, let's start by just learning a tiny little bit about your background and your research work right now, because that will set us up for everything that will follow.
Yeah, so my research actually, dialing back 20 years, was in statistical machine learning. So this is actually, all of AI these days involves statistical machine learning. And this is something that really picked up steam in the 90s. And during my PhD in the 2000s, that's where we laid a lot of the foundations for the statistical machine learning in terms of figuring out statistical associations between a lot of data and making predictions and so on. So all those foundations are right now being used in all the state-of-the-art AI models. And so fast forward to the present. So now I'm really looking forward to the next evolution of AI beyond statistical machine learning. And I'm sure we will talk a lot more about that today.
Yes, indeed we will. And that taps into this big thematic distinction that we'll get into between statistical and symbolic approaches to machine intelligence, because I think it's fascinating and it's so crucial for everyone out there to understand if they want to think about where this is heading across the next few years. But let's start with where we're at right now. I mean, it goes without saying, for most of us out there, the AI moment we're living in now, ChatGPT, Midjourney, generative AI, all of that, it came as a huge surprise. Where do you think this is heading across 2024? Because so far we've had huge excitement and a degree of wonder with the capabilities and the outputs of these models. It feels like, we've done that now. And the questions are more around, or the questions I'm asking myself are more around, How does this have an impact on the real economy? Where does it head across 2024 in terms of jobs, economic impact, and so on? How are you looking at that? And how are you looking at the role of the big players, OpenAI and DeepMind in all of that? Can ChatGPT have an impact on the real economy, or is it just not ready to?
Right. I think yes and no. If you think about ChatGPT and large language models, they are very good, great even, on figuring out statistical associations between word sequences and understanding essentially just collection of words. But with the more modern multimodal foundation models, they can also understand images, even audio, and all of these things together. And so basically an upshot of this is that if we have data that consists of images and text and audio, then we are going to have these AI models that are going to understand what we want from them. And I think this is going to be a big unlock because if you think in terms of how, let's just say, we participate in the economy, let's say there is a manager and he or she wants their direct reports to do something. They typically convey this using audio, using text, potentially images, right? Maybe we communicate using memes. But the interesting thing is that if you can have AI models that can understand this, then that's a potentially huge unlock. And so I think what we might see over the next year are what I would say are things both above and below these large foundation models, where you can have things above, where you could basically have these large language models suggest certain tools to use. And then you could have other wrappers that can use those tools. And then you can also have things below where it can clean up how you interact with these foundation models. And so I imagine that there would be a lot of companies in that space that can help us do that. But at the same time, I would say that it's not all of the things that we want to do take the form of analyzing text and images and audio, right? So I think that's going to be a realization that we're going to also see. So there's going to be these positives that I mentioned, but there also could be potential negatives, or I don't want to say disillusionment, but because I think there are going to be other solutions along the lines of what I'm going to talk about later on. But people are going to realize that just the large language models are not going to work if you have data that is not just images and text.
Hey everyone, have you yet checked out the incredible, groundbreaking new Real Vision platform? See, we've built something that allows you to live your financial life in one place. We bring together the knowledge, tools, and network to help you thrive in your financial journey. We've got AI tools to help expand your knowledge. We've got courses and education. We've got note-taking. We've got pricing and charting. And in addition, we've got obviously the world's best content, both on macro and crypto, to bring everything together. And in addition, you get access to the Real Vision network. That's our tens of thousands of members across the world where you can connect and chat to them about what really matters to you. Anyway, it's free, realvision.com. We'll see you there.
So, yeah, I mean, essentially what ChatGPT and other similar tools fueled by large language models can do is understand your text inputs, your language inputs, and spew out some new text. Mm-hmm. And there are instances in the workplace where that is useful, right?
Right.
Do you think that can eat jobs yet?
Technology has always, so one perspective of technology is that it takes energy and transforms it into something instrumental. And by and large, if you think about, I guess, the Industrial Revolution and 100 years back, a lot of it was in the physical world. But if you think about even our jobs, right? So for instance, we are communicating actually on video or the internet right now. And so a lot of our jobs don't actually involve the physical world, though again, there is some physical infrastructure for the internet. A lot of it just involves the world of ideas. A lot of our jobs involve ideas and moving ideas around. And there is an interesting question on whether you can take energy and transform it in an instrumental way to move ideas, not just atoms. And if you think about a lot of the jobs we do, including personal computers, and we have Microsoft Word, PowerPoint, a lot of it are tools, technology that help us do that. But it's basically a lot of steps, very laborious, and we can think of a lot of the new wave AI models as essentially simplifying those steps. And once we do that, that's such a huge unlock for humanity that I think it'll create more jobs rather than just destroy jobs, because there are many companies that just won't be feasible using basically our current set of technologies. And so, for instance, if I have a very, very enterprising entrepreneur in India, say, and they do not have enough funding to have a team of 10 people. So this is a company that's never going to exist. But with these tools, maybe it exists. So I wouldn't think of that as, so let's just say they start this company with 2 people instead of 10 people. I wouldn't say that you lost 8 jobs. I would say you gained 2 jobs, because that's now a company that wouldn't have existed. And in fact, if you look at the downstream effects, then that would actually create even more jobs. So I think I'm pretty excited about the possibility of essentially using energy to change things in highly interesting instrumental ways.
Yeah, and that's such an interesting perspective, because one of the big questions I'm asked, and one of the refrains we constantly hear about ChatGPT right now is, oh, what about my job? Any knowledge worker, many knowledge workers, what about my job? I'm concerned about my job. Is it going to eat my, my task in the workplace? It doesn't feel as though ChatGPT is sort of competent enough or
right,
multimodal enough, right, to just eat an entire person's job, even if their job is essentially knowledge based. Would you agree?
Absolutely. And this would also tie into some of the discussions we're going to have later on, where I think a lot of what ChatGPT and these large language models are going to do, I think are best understood as productivity enhancers. They are not going to be end-to-end solutions, because we cannot trust those as end-to-end solutions. So for instance, Microsoft has this GitHub Copilot, where it suggests code snippets based on various specifications you may have, and it even takes your existing code and tries to complete it forward. But you cannot trust it completely. So what I find is that it enhances the productivity of a programmer by 2x, 3x, but it cannot replace the programmer. So you still need the programmer. And will we ever get to a place where we can use this end to end? Not in the near future.
Yeah, and that's a really interesting perspective, and potentially a reassuring one for many people out there. And it has to certainly aligns with mine, and it has to align with most people's, anecdotal experience of using, for example, ChatGPT, which is exactly that. It feels like a sort of jetpack for the mind. It feels as though it can enhance your productivity, but you can't just set it. You can't just set it off and have end-to-end replacement of entire tasks.
So actually, if you look at the word Copilot, Microsoft actually gave a lot of thought to what do we call this device, and they are calling it a Copilot. So where it's very clear to the people using the system that this is something that is a companion, that's something that's going to help you, but it cannot be something that is end to end, and you cannot trust it fully. But at the same time, you can kind of interact with it in a very different way and so on. So you can kind of learn how to interact with it, but it's still a co-pilot. And I think that was very smart nomenclature that exactly captures what it is.
Yeah. I think that was a very sort of wise choice of words, and an accurate one. And so you have that sense of it being these tools being a productivity enhancer, sort of letting us think further, faster, I suppose. And I also love your perspective on the way it can help create jobs, because as you say, you might have a company that needs 5 employees, but it can't possibly afford that. Well, now it could have 2 employees plus a whole lot of AI. And you haven't lost 3 jobs, you've created 2, because that company otherwise would not have existed. So do you see already where we're at now with these large language models and tools like ChatGPT? Do you see that sort of democratizing startup culture and the ability to do your own thing and start your own thing? That's part of the path we're on that I find interesting.
Absolutely. I think this is something that we can think of as there are certain tools. Microsoft had wanted to do this with just computing itself. So this was actually Bill Gates' vision, which is that he wanted to bring the power of computing to individuals. He wanted to democratize access to computing to individuals. And of course, we have gone far from that. We now have smart devices rather than just desktops sitting on our tables. But now, if we move that forward, we not only will have computing devices, but we will also have programs, ways to interact rather with these computing devices that is more democratized. So we can think of programs as one way in which we communicate with these machines, these personal computers. And this was a language like the priests of yore, where they have speaking in, strange languages to these strange machines. And we needed to intermediate our interactions with these machines through these priests, which are these programmers. But if we can allow non-programmers to also interact with these machines, wouldn't that actually accelerate or be actually a more natural next step of Bill Gates' vision of having computing devices at the hands of everybody, but also in a way where they can interact with it fully? I can ask my smartphone to do certain things that I have in my mind, but I'm presently not able to do so because I won't be able to create an app. But now, if I can do that, isn't that amazing? So I think that's actually a very, very exciting frontier, I think.
It is hugely exciting, isn't it? And I mean, if you're roughly our age, right, you obviously remember the whole, the birth of the App Store, and back in the sort of early 2010s, I guess it was, when every third friend you had was creating their own app. And the constraint on that for many people is that they couldn't code. Everyone had an idea for an app they wanted to make. Most people can't code, so they simply couldn't make that app.
Right.
My feeling is we're removing that constraint.
Yes, absolutely. Or at least reducing that constraint a little bit. So it won't be as simple as our grandma being able to code an app just from scratch. So we are still not there yet, but we are definitely reducing the barriers, I would say.
Yeah. So the potential for a sort of flourishing of creativity around computing is huge, because
right,
to a much greater extent, it feels to me, if you can imagine it, you can have a go at creating it, whereas that simply wasn't true before.
That's right.
Everyone on Twitter, or X as we're now supposed to call it, is excited today about the launch of this new R1 Rabbit device,
right,
this little device that it is like an AI companion. There's also the humane AI pin.
right.
So we're seeing this incredible, the burgeoning of this wave of innovation around these AI companion devices. Do you think that's going to become a bigger part of the story in 2024 and a bigger part of people's relationship with AI across the coming year and beyond?
I love the vision at the very least, but I'm a little bit skeptical, I have to say. So I love the vision of reducing friction. So Apple is very good at this, where many people completely underestimate and underrate friction that prevents us from various tasks. And if you think about Apple, they try to make these devices so that the friction to using those devices is reduced. And if you think in terms of natural language interfaces, that reduces friction. So if I want the computer to open a particular app, instead of me opening the computer and then trying to find the app, if you can just say, please open, DoorDash, and it opens it, that's great. And simple things like this, I think, can be enabled. But I think if we wanted to be a full-fledged companion in terms of saying, hey, book me a flight to London the end of this month, I'm not sure we are there yet. So I think if we dial down our expectations for these companions, I think we are definitely going to get something. But I think to have a completely have a computing device that is going to be completely disintermediated in the sense of all interactions that we have with these. If it's completely going to be intermediated by natural language and audio, I don't think we are there yet. I mean, Amazon tried to do this with Alexa, where they tried to, and Alexa is pretty good, right? So voice recognition is pretty good. They try to get people to do various things with Alexa, and they failed because there's still the just amount of friction. It's not perfect. And if it's not perfect, I don't want you to book a flight, right? So I think that's essentially the problem.
Yeah, exactly. And I think they're going to have to play with kind of voice and audio and screens quite a lot to find the perfect combination of the two, because when I book a flight, I want to be able to see the options in front of me. It's no good just telling me what they are.
Right.
I think that those details are crucial. It's going to be I mean, my other concern for those startups like Humane and the little rabbit device that's going on now is, aren't they going to get crushed by Apple? Like when Apple puts a large language model on its devices and can just roll that out across 1 billion people, don't you think?
Absolutely. I think if Apple or Google, for that matter, they do have this Gemini Nano that they already plan to push onto their Pixels or Pixel Pros, that's really the next frontier in the sense of having these powerful models on our computing devices natively, so that they don't need to communicate through the internet through some server and pay some cost and so on. Once we have that, then it is, I think, a worthwhile question to say, do I need a PIN or do I need a completely different device? Probably not. I would definitely agree. But on the other hand, companies like Google and Apple are not going to roll out half-baked products, right? So they won't roll out something unless it's close to perfect. Especially Apple, they love to reduce the friction, but they're not going to release something unless the friction is completely gone. And so I think there's still some time for a company like Apple to actually release something. So I think in the next 2-3 years, these companies have, I think, a free reign. Maybe they even get acquired by Apple, for all we know. So there's still, I think, a good space to explore, potentially.
Because the dream with Apple is some sort of vastly upgraded Siri, and maybe they don't call it Siri, that is a true on-device virtual companion that just knows everything about you, and you can talk to it. It's like a counselor, it's an assistant, it's a friend. But you think do you think that Apple have not done that yet because it's so hard to perfect? And we know they're a perfectionist company.
Exactly. That's really what is stopping them right now. It is always possible to roll out a half-baked product right now, but Apple won't be the one to do it. And so they are going to wait. And just even after coming out with the product, they're going to experiment with it. And from a technological standpoint, we are nowhere near the place where a company like Apple would be happy with the product. So we are just not there.
Now, speaking of the next frontier for machine intelligence, let's really dive into this, because I know that fundamental to your work is this idea that to really move beyond where we are now and to really see an impact on the real economy, sort of a deep economic impact, we need to move beyond the focus on the statistical approach to machine learning that sort of governs this moment. So this can start to feel somewhat technical. It doesn't actually have to be that technical, really, and you explain it so brilliantly. So let's get into all of that. Just let's start by talking about what we even mean by, statistical and symbolic approaches, and what it is about the current moment that makes it the statistical moment. And that means diving in a little bit to the history of AI, doesn't it?
Right. Yeah, absolutely. Yeah, I think it's I think a great point to talk about the history of AI. So if you dial back all the way to 1950s, when we had these powerful computing devices, people thought, oh, that our next thing is to just build AI. If we have powerful computers, how hard is it going to be to build AI, right? Is what they thought. So the first wave of AI was using what are called symbolic approaches. They are so called because if you think about any beliefs we may have or any statements we may have. So for instance, let's say David is a great journalist at Real Vision. So this is a statement, and I can basically have various symbols to represent this statement. There's an entity named David, who's a person, and who's a journalist who works at Real Vision. And so all of these I can have symbols to represent this knowledge. And then I can also have reasoning to go from certain propositions to certain other propositions. So for instance, given all of these statements, I would then perhaps have another proposition that says David does great interviews. And so that's a reasoning step where I go to a completely different proposition and go from A to B. And these were the kinds of programs that people were building early on. And we can think of these as largely rule-based systems where these rules operate on symbols. And the heyday of these were actually in the 80s and including in the 90s, where one prototypical instance is called Dendrol, where what it was given compounds, so let's say hydrogen peroxide, H2O2. So given various measurements, I think spectrographic measurements, maybe I want to know the composition of this compound. It's 2 hydrogen atoms, 2 oxygen atoms. And they built a system that was better than organic chemists. And the way they did this was using a bunch of rules. So they had various symbols related to the measurements. They had various symbols related to the atoms, and they related the measurements to the atoms and so on. And so given the measurements, looking at these rules, it'll say, oh, I think it's hydrogen peroxide. And there were these things called expert systems that were these gigantic rule-based systems sitting on top of symbols that people were building in the 80s that, again, the similarity to the present is quite interesting, where the companies and industry was spending millions upon millions of dollars to build these large-scale systems, and people thought that this was the future of AI. And it turned out not quite. Interestingly, Deep Blue, that beat Kasparov in chess, was another instance of such symbolic approaches, where there the symbols related board positions and particular actions that you can take. So I think there are 64, I forget how many exact moves you can make from any given position. But what he can do is that he can roll out. So I will play, a particular position, then the opponent could play any of other 64 different possible positions, and I can just completely roll this out till the game finishes, and then see if I move my, knight to this position, then do I win? And I can just roll this out, but this obviously will take too long. And so they had various tricks to reduce basically the search. And this is how basically Deep Blue beat Kasparov. It was all very kind of rule-based approaches. But like I said, this kind of fizzled out because this was too laborious. Because where are you going to get the symbols? Where are you going to get the rules, right? But then where there was a little bit of despair in the late 80s came this new field called machine learning, where, let's take the dendrol example. So I have certain measurements, spectrographic measurements, and then I have what the compounds are. And instead of having organic chemists provide rules and what the symbols are, what are atoms and whatnot, what if I just give it training data that says that, okay, here are the measurements, here is the compound, here's are the measurements, here's the compound. I just gave thousands and thousands of such mappings and let the machine learn how to associate bits of the input. There are statistical associations between parts of the input and the parts of the output, and it will automatically learn that. And so this was the statistical learning phase, the second wave of AI, that really picked up steam in the 90s and 2000s. And if you look at 2010s, there was a even further boost in terms of these architectures called deep neural networks that, together with the foundation that people built, really turbocharged the statistical revolution. So that's where we are presently in terms of where AI is.
Yeah, thank you. And I mean, it's just such a fascinating and expertly delivered, very brief history of machine intelligence. And so you have, the initial first wave, which, as you say, almost grew with the birth of computing itself. Right. There was an almost naive optimism that we've created computing. It can't be long until we create a human-like intelligence. And the route to that is via symbolic representation. Am I right in understanding that part of the reason that fizzled out is because that symbolic approach can be effective for highly structured, sort of rule-bound domains, like, for example, chess? It's a very structured, rule-bound game. I mean, there's literally a set of rules. Right. And you can sort of hard code those rules in. It's pretty laborious. Right. And then apply just brute force computational power to get answers. But if you think about, for example, how do we get a car to drive around, the open road? There's no set of, there's no strict set of rules for dealing with all that elements. It's an extremely fluid environment, an unstructured environment. And that's where the symbolic approach tends to break down. That's my amateur understanding, compared to yours, understanding of this. Is that right?
That's absolutely right. So where the symbolic approaches were basically incomplete for complicated domains. Incomplete meaning that they were not able to capture all of the things that are going on. Like, for instance, you talked about cars driving. So there are a lot of things that are going on in terms of the environment. And can you have symbols and rules that capture everything? If you can't, then it's incomplete. That's number one. Number two, the rules may not also be what we call sound, in the sense that I may come up with a rule that says that, if you see a car in the other lane, then don't switch lanes or something. But in certain cases, you may need to violate that. If, let's just say, another car is just coming speeding behind you, you're just going to switch lanes no matter what, right? So there are many instances like that where rules can be wrong. So they are mostly right, but they are not going to be perfect. And so that's another big part of why the symbolic approaches failed. There is also, you talked about chess, right? Where with the Deep Blue system, it is very, very computationally intensive to roll things out in terms of, okay, so I will play this and the opponent will play that, and what's going to happen. And so they needed a supercomputer for this. But these days, using statistical approaches, we have very simple, very small programs on our computers that are even better than Magnus Carlsen, for instance, or any human chess player. So it turns out that even in highly closed domain settings, it is computationally better to use statistical approaches. And so for all these reasons, but primarily what you, I think, so nicely talked about is where the statistical revolution really won out. And that's where pretty much every AI system that we are presently using uses the statistical machine learning engine.
Yeah. And I remember the huge excitement when Deep Blue beat Kasparov, and it's kind of mind blowing now when you load a chess program on your phone and realize that it's more powerful than any human chess player has ever been.
Right.
That was kind of one of the high points for the symbolic approach, certainly in the popular consciousness. ChatGPT, I think it's fair to say, is one of the high points for all of us and in the public conversation for the statistical approach, right? Because large language models represent the statistical approach.
That's right. So yeah, if you think about these large language models, the way they work is that I have a sequence of words and I need some way to compactly represent the sequence of words. So let's just say the sequence of words is an entire novel, right? But we need some way to just summarize that in some fixed length storage. But then given this, I also need associations between this and what will come next. And so this is basically figuring out statistical associations on steroids, where I want to compactly represent a sequence itself. I need associations between parts of the sequence. And then I'm going to figure out statistical associations between word sequences and what's going to come next. And this turns out to be very good with things like grammar, because that's basically what grammar is, right? Where you see all of these things and what should come next. There are certain rules that we have, but these rules are, again, quite complicated. Sometimes you follow them, sometimes you don't. It's complicated in many ways. And we presently are using these large language models to automatically figure it out just from statistical associations with a large amount of data.
So you have these models essentially learning about the deep statistical relationships between words. That's and right. Even parts of words as we, use them in the English language, trained on this vast amount of text. And that just gives them people have been surprised at how competent that makes these models at producing language that pretty much sounds as though it could have been produced by a human being. I mean, that took even experts like you by surprise, right?
Absolutely. I think nobody expected these statistical association-based models to be so good. We always knew that with bigger models and with more data, these models would get better. So that there was no doubt about. But the capability that we are seeing, that has really caught even researchers by surprise, definitely. What it suggests is that a lot of, statistical associations capture a lot of the things that we care about, but not all, as I'm sure we will come to.
Yeah, well, exactly. And let's come to that because, I won't give the game away for you, but essentially you believe that to move to the next big to really advance from where we are now, and in particular to see an impact on the economy and to make this AI moment truly useful and impactful, we need to move beyond this statistical approach moment. Talk to us about that.
Yeah.
Why are we hitting the limits? What limits are we hitting when it comes to the statistical approach? And why do we need to move on to get to a more useful place? And what does that look like?
Right. So if you think in terms of a lot of a formal knowledge, let's think about, let's say, number theory or algebra, linear algebra, and so on. So some of our advanced math courses, then a lot of it is relationships among different things, right? Relationships between numbers, relationship between symbols. And it is not always the best thing to talk about this knowledge in terms of statistical associations. So for instance, with number theory, right? So I may have various theorems involving primes, for instance. And it is not always possible to represent this knowledge by saying that, okay, so if I see 1 and then a plus and then another 1 and an equals, then the next thing should be 2. Now, this is an important number theoretic fact, but it is not always possible to just represent all of number theory just using these statistical associations. It is also not efficient to do so. So it's both a capacity as well as efficiency reasons. Let me actually give an example, an application that we in our present day may want. So let's say I'm a hospital system and I have a little bit of unstructured, a little bit of structured data in terms of what my doctors are doing, what are treatments they are giving, how the patients are fed, how much it costs, how much the hospital is making. And if you think in terms of what the hospital administrator might want, they may want certain insights in terms of what are certain procedures that are costing the most or are the least cost effective, or things that are most helpful for patient outcomes, who are the doctors that are really good. These kinds of insights have numeric reasoning that is critical to come up with those conclusions. Or let's just say I'm a company and I have a whole bunch of branches, a bunch of shoe stores. Let's say I'm Nike and I have a bunch of shoe stores, and I want to look at the results of all of the shoe stores to figure out what are things that are working, what are things that are not. And so here I need to do numeric reasoning that is much, much more complicated than just simple statistical associations between symbols like numbers. And right now, if you're going to use ChatGPT or large language models to surface these, it's going to hallucinate. It's going to think of statistical associations that could be interesting, but by and large, are not going to be useful. So what we really need is essentially the kind of, I think it's interesting to think about the kind of human culture itself, our scientific enterprise itself. We have developed things like algebra and other number theory and so on quite late, right? We had developed language 70,000 years ago. But, and if you think in terms of associations between bits of images and whatnot, that actually goes back to potentially the Cambrian explosion millions of years ago. All species have vision, for instance. And what is vision but statistical associations between all of pieces of the image? That's the only way a lion is able to say, hey, there is a gazelle, I should go and eat it, right? It has these capabilities, but it wasn't able to develop algebra, right? So we need this additional capability to do the kinds of things that companies want. And there is a reason, lions didn't develop algebra. Similarly, I think we need to have this additional component that does this kind of numeric, symbolic reasoning and calculations that we can rely on.
Right, right. So to make this truly, for many corporations, many startups, to make this truly useful, and therefore to have that kind of big impact on the economy that people are talking about right now when it comes to AI, in layman's terms, we need to make it good at maths. It needs to be able to handle numbers.
Yes.
I'm kind of Unilever. I have like endless data about sales and kind of supply chains and all this. And right now, a large language model can't handle that. I mean, we can all step to Chat GPT and see for ourselves that it can't really do maths at all.
That's right.
How do we, and this is where some of your work, you can talk a little bit about some of your work. What it sounds like what you're driving at is essentially a new fusion of the symbolic approach and the statistical approach in terms that we ordinary mortals can understand. How are we going to do that? How can that work? And then I'm interested on your thoughts on who is going to do it, who the winners could be here, because we're talking about a big next evolution for AI with potentially massive rewards for the players that get it right.
Absolutely. And so here, I think, so if you think about the first wave that is symbolic, the second wave of AI that was statistical, we need a third wave of AI that is both statistical and symbolic. Some people call it neurosymbolic by associating neuro to the statistical revolution. And so what we really need are the statistical symbolic or neurosymbolic third wave of AI that combines both of these. So one way to think about this is maybe, again, going back hundreds of thousands of years, right, to human evolution. So we have a prefrontal cortex that evolved at the very end. And if you think about other parts of our brain, our neural architecture, that's basically what our statistical models are. It's all about statistical associations between bits of the input. And our older parts of the brain are already doing that right now. But if you think about the evolution of our own brains, mammalian brains, then around, I would say, a few 100,000 years ago, bits and pieces of the prefrontal cortex started getting evolved. And I think if you look at actually Homo sapiens, I think it was maybe, again, a few 100,000 years ago where it fully developed. So what is the difference? Why do we need the prefrontal cortex? It's basically symbolic reasoning, sitting on top of the kind of statistical associations. So what we really need to build is the prefrontal cortex that's kind of, we can evolve it at the end, but now I think is the right time where we now have evolved the other parts of our brain, done a reasonable job with that, but we need to have this more symbolic element. And I think a lot of the architectures that people are exploring are along similar lines, where you actually have something that sits on top and that synthesizes, that we can think of it as a hierarchical architecture, that you have a more symbolic module that sits on top of this statistical module, and that synthesizes things into symbolic elements and does reasoning with it. So a lot of this people are still developing. So I can tell you that DARPA is investing heavily in this, in third wave AI. So I'm part of basically, so DARPA has funded my group as well. And they have funded a few groups all over the country to push this neurosymbolic AI forward. DARPA is always forward thinking. So whatever DARPA is doing, it's going to be the state of the art in a few years, in 2-3 years. So you're already seeing, so you talked about the rapid companion. So if you look at the presentation that the CEO made, you may have heard the phrase neurosymbolic.
Yeah.
And what I would say is that you are going to see this phrase neurosymbolic more and more in successful companies, because you do need this third wave to actually build something useful. And really, that's I would say in a year or so, you're going to get, again, I don't know how much Rabbit is doing in a neurosymbolic direction, but I think in a couple of years, by 2025, you're definitely going to see companies use this neurosymbolic technology in some way, at least.
Do you think this is the direction OpenAI and DeepMind are pushing in? Because we all noticed at the end of last year, DeepMind's Gemini multimodal model is apparently very mathematically competent. Then there was some ruckus about how much of that demo was a little bit massaged or faked, but it does seem to have maths competence. Have they achieved that by, as you say, kind of bolting on some form of symbolic reasoning to the underlying statistical model?
Not yet.
Right.
The way that some of these companies, again, there could be different approaches that they are taking, is, so one example, which actually Google came out with a year or so ago, is called chain of thought, where it is, if I think in terms of, 1 + 1 = 2, it is good at figuring out just from the statistical associations what should come next. But if I have a long word puzzle and I'm asking it for the answer, it won't be able to do that just from statistical associations. But if I ask it to go step by step, then each step it may have seen from the statistical associations in the data in terms of what should be the next step. And by forcing the model to go step by step, you can actually do a better job than what it was doing previously, but it's still not this kind of a neurosymbolic thing where it's still not something you can trust. And so right now, these companies are still in the statistical wave and not the neurosymbolic wave, primarily because there are many, many ways to do that, and it's still not fully clear. We are building the foundations of that. So I would say, but things are moving so fast. So I think it's still a year out, I would say, in terms of how to achieve this.
Yeah, but I mean, this is so profoundly important for people to understand that we're in this this statistical wave right now. And the next big wave is coming, and it's going to be about this fusion of the old symbolic approach updated for a new age with the current statistical approach. We're going to hear a lot more about, neurosymbolic AI. And just as you say, and I love this comparison to the human brain, and we'll talk a bit about that in a second. Our brains do both. So if the dream is a thinking machine, a machine that is in some way comparable to the capabilities of the human brain, you would expect you have to have both approaches.
That's right.
Who else is positioned to win? I know you have some interesting thoughts on that. OpenAI must be thinking about this. DeepMind must be thinking about it. Who else?
I think OpenAI and Google and so on, primarily because of their business models, are focused on modalities like text and images, because that's where the large amounts of data lie. You need that to build the statistical models. But if you think in terms of where neurosymbolic methods are required, it's probably going to be in domains where you do not have such large-scale data. And I think probably the dark horses are going to be companies that are working with data. They are working with databases. So I would say Oracle is an example of a company that is working with databases. So, if you look at most enterprise customers, a lot of the data they do have documents and images, of course, but a lot of the data are in relational databases like Oracle. And there are, of course, other companies as well. But if companies like Oracle can take some of the bones of the statistical revolution, combine that with the symbolic components and have a neurosymbolic solution, that can mimic how, let's say, human data analysts work with these databases. Databricks would be another example, but these would be the kind of dark horses, not just Google and OpenAI, where a lot of what they are developing are probably going to be commoditized to large extent. But again, we can never tell how much things can be commoditized, because if you think about Google search, why wasn't search commoditized? Why is Google still so predominant in search? Because that's just retrieving relevant web pages from a corpus of web pages. We know the technology. Why aren't there million competitors? So I don't want to say that I'm sure things will be commoditized, because there are network effects, or there are not network effects, but I guess there are kind of, if people are using something, they'll continue to do so. But I think that companies that are going to push in this neurosymbolic direction for enterprise customers and other customers, because again, if I think in terms of our own everyday life, so we have our health monitoring devices, and all of those are numbers. So I want my AI to understand me in all my numeric glory. And for that, we need neurosymbolic models.
Right. And I mean, Oracle are fascinating, obviously tech giant, but not one that people would immediately step to when you talk about the future of AI. So many of us will have heard that here first, and we will be watching Oracle and this neurosymbolic wave that's coming with great interest. And as you say, it's going to be super interesting because, of course, OpenAI is trained on a massive amount of text that was just sort of free floating out there that they could just grab. And that's now somewhat controversial, but essentially they just hoovered up a whole ton of like human culture and used it to train this model. There isn't necessarily the same giant numeric data set, right, just floating around out there. So it's going to be the people that have access to those kinds of data sets that are positioned to win here, right?
Exactly. That's right.
Yeah. And so that's where someone like Oracle comes in. And, if they have a ton of structured numerical data that they can train on, even if they train something that only people using, Oracle databases can use, that's still massive. Yeah, it's very, very interesting. Okay, look, it's just been, thank you so much for joining us. I mean, we could go on for another hour. It's such a fascinating conversation, and we must have you back, because the unfolding of this big third wave, which I don't think many people yet are aware of, but is coming and is so important. I think it's a fascinating story to track, and I'd love us to track it, through the year, through the next few years. I know many people out there will be watching and wondering on something you said earlier, or one of the themes you touched on earlier, which is, look, excuse me, this kind of mirrors the way the human brain evolved. We have this underlying statistical approach, right? But then we evolved this sort of symbolic representational intelligence too, and human intelligence is about both.
That's right.
Does that mean that this fusion of statistical and symbolic is the route to the fabled AGI, a truly generalized human-like intelligence, and then even super intelligence?
Right. So there's a joke, right, where they say that if you don't have any idea when something's going to occur, say it's going to be 20 years out, it's going to be 30 years out. And so you have all of these surveys that say, that researchers say that, oh, it's 20, 30 years out. You should always take that with a grain of salt, because whenever somebody says something is 20, 30 years out, they're essentially saying, I have no idea, right? So maybe it'll occur, maybe it won't. I think understanding the kind of human intelligence, or even it doesn't need to be human, having a completely general intelligence is a very, very ill-defined thing. I mean, being able to understand language and images, ChatGPT or large language models can already do that. And that is a general intelligence to some extent, I would say. But it's still, I would say, very far from the kind of general intelligence that we would associate with humans. So I think AGI, in the very ill-defined sense that people have in mind, is very, very far away. I would in fact make the bold claim that it's not 20, 30 years away, it's 100 years away. Because if you, again, think about the waves of AI, we had the first wave that mirrored the computing revolution. And then you had the second wave, the statistical revolution, which, again, a lot of it was developed over decades even prior to the development of computers, because the field of statistics is much, much older. And regression was developed by Galton in the late 19th century, for instance. But I would find it interesting that regression came after calculus. It's a more subtle, statistical associations are more subtle to develop algorithms to infer those are more subtle than even calculus. But that took so many years, I wanted to say, because, now we are coming up to this third wave, which is also to flesh this out fully is going to take many decades. We will come up with solutions, don't get me wrong, but to fully flesh that out is going to take decades. And that's just 3 waves. And it seems hubristic to say that that's all we need, right? This is what we can see presently, but there are things like, for instance, our working memory. So here is a mystery. Our working memory in the prefrontal cortex can only handle 10 symbols at a time. Why is that? What is so critical to having 10 symbols? That cannot just be a capacity thing, because our brains can handle a lot of things. Why? So we have no idea, right? And there's just so much we don't understand. And I imagine that there's going to be, 5, 6 waves of AI. It's going to take 100 years. So it's probably a problem for our grandchildren, probably.
Right. A fascinating perspective. And certainly it feels to me that the reflected light this journey is throwing on the nature of human intelligence and sort of essentially how much of that we don't understand is also a thrilling part of the picture. But look, Pradeep, thank you so much for joining us. Absolutely fascinating conversation. Where online, if anywhere, can people learn more about you and follow your work?
My website is where all of my research is available. I just came onto Twitter a couple of days ago.
Aha. Well, you have some fun in store. Welcome.
Right. So
it's not always, it's not only highly civilized and sort of intelligent conversation about machine learning. I hate to tell you, but it can be a lot of fun.
Right. So so I guess it's in the second wave. It's all in the statistical associations.
Well, he's training his own model, isn't he? Grok.
Yeah.
So we'll see how that plays out as well, especially with an election coming up. But okay, so your website, people can Google you, find your website, check out the fascinating work you're doing. Thank you so much for joining us. And like I say, please come back in future, because we will be tracking, of course, continuing to track this incredible AI moment we're living through, where it's heading, what it means for all of us as professionals, as investors, as human beings, what it means for the economy at large out there. We'll be continuing to track all that, and the exponential age theme on Real Vision all through this year. And I cannot wait. It's going to be a fascinating ride. But for now, Pradeep Ravikumar, thanks so much for joining us, and everyone out there, see you soon.
Thank you.
Hey there, revolutionaries. To join a community sharing insights like you just watched, head over to realvision.com. There you will get unbiased insights and exclusive access to the very best, brightest, and biggest names in finance. Be a part of our community of lifelong learners. See you there.